mate. Okay. Now you are going to, or you are being tasked with a sort of a twist in the project. Not only that you have to average those financial numbers, you need to now, you're switched to another project where you have to average past years uh, temperature because of sustainability and environmental stuff. So not only must you look at profit, you must also look at weather. All right. So let's say you start off a new file doing weather. Then what is involved? Well, you were told to also calculate the average of past 3 years. Now, obviously, in real project, it can be different number of years. Suppose let's just restrict the complexity and say that you need to calculate average again. All right, and it's about average of recent 3 years. Kind of makes sense too. So what do you do? Well, you can sort of record the data. We have more fanciful ways to record lots of floating point data, but let's just stick with our three um, nicely named variables that store past year data. Okay, so we are supposed to average up these three values. One way is, of course, we repeat again the calculation, right? The formula year one temp plus year two temp and so on, then divide by 3. But again, as we try to understand the average formula, fortunately it's easy, but what if it is complex integration? Don't tell me we have to rewrite the whole numerical integration or whatnot. What happens if it is complex graphics interface program? Don't tell me we have to rewrite from scratch all the graphics low-level routines. We don't have to. So in this case, you recall that some time ago you have written calculations and it was about averaging 3 numbers, right? And you want to reuse this logic because the logic is the same. Just that in one application it was financial data. In this application that you are busy with now, it is the weather temperature. Can I reuse the logic? Answer is definitively, right? So in Python, it is very easy to do that. First, I created this file in the same directory as the calculations.py. Let me save as calculation-use. Okay, so I'm just going to rewrite it. It's fine. I'm going to rewrite it. And I want to make sure that the current directory that it is running in is in the same directory as calculations.py. So for me, I go to Python over here to select, yeah, I select d:10 Python online, which is where I find my calculations.py, because that is the module I'm going to pull in. I'm going to suck in the logic there, right? So just to check, we can go into our interpreter and say import OS, that's the operating system, and say OS get CWD, current working directory. Where am I? Yes, I'm correctly at that particular folder, inside which is calculations.py. So now I just simply say import calculations, finish. When Python executes, upon encountering import, remember, import creates a new namespace. So it will suck in all the codes in calculations, and all I need to do is to say year average is calculations dot average. Remember, yeah, average doesn't exist in our current namespace. If you did not include calculations dot, Python will search your current namespace and look for average and says, sorry, you didn't define average. So here, recalling that our average function takes in 3 numbers, we simply provide 3 temperature numbers and print year average. Okay, and let's see. It works. It works perfectly. You see that? So we got the average temperature. And we did not rewrite any single code involving average. Again, I invite you to think about the average as a super complicated procedure and algorithm that we need to write hundreds or even thousands of lines of code to do that. And this is so simple now. We just do it once. See, so when we write single purpose functions, it is really very powerful. Whenever we think about average, we just say, oh, I think it's stored in this collection of codes called calculations, and put it in. Now, what is not so single purpose? will be something like this, right? Suppose we write an average function. I want to keep all the code there, but we sort of like not practice this single purpose function. So it's an X average. And we say, well, my average is super powerful. It will take into its calculation 3 data plus a command, all right? So we'll kind of have this powerful average function where returns the average of 3 numbers if CMD is 1. Okay, returns differences of 3 numbers if CMD is 2, returns and so on and so forth, right? Product of 3 numbers if CMD is 3, and returns division of 3 numbers if CMD is 4. Finally, returns average, returns the sum. And finally, returns average of 3 numbers if CMD is 5. Okay, so now how do we implement this? We need to check. If command is 1, then we return the sum of the 3 numbers. So you get the idea, right? You're like having this plus minus times divide all in. If command, however, is 2, then we execute x1 minus x2 minus x3. So it's a very powerful super duper function. You know, it does everything. It's no longer single purpose. Yeah, is it good or bad? That's the question. Yeah, we are programming all these. Do we require all these addition, subtraction, division right now? At this point in time, we're just preparing for future imagined scenario, right? So we are not really sure whether all these features will be used. We're just writing for the sake of writing, and we're making this function multi-purpose. Although we call it average, actually it's also sum, it is also difference, it is also product, it is also division. No longer sure what it means. Okay, so if we save this, and if we run average x, we can. All right, so suppose we save this in the package, in this module called calculations, and when we use it, all right, we can always say, oh, I need to calculate the total of 3 years temperature. I remember in the calculations package that there is this weird function name called average x. If you give it the right twist of the command value, it will be able to calculate the sum total instead of finding the average. Right, so if I give it a 1, then we expect the total temp to be the sum instead of average. So let's run it and see. Right, so indeed it carried out the sum total of 3 years temperature. Not that it's meaningful, maybe as a partial calculation, who knows, right? The idea is this is totally not descriptive of the sum total calculation. And also, you might do a difference in temperature, but you also see that your function is average x. It's very confusing, right? So all you need is, what you are forced to do, however, is to say, what is this magical 1 over here? And you have to look at the code, and if this is not a 10-line code, but a 100,000 line code, I'm exaggerating, but if it is even 200 lines of code, you will likely give up halfway and say, well, I'm sure I will be even quicker if I just write it myself. Yeah. So if you plan for your code to be used or reused by your teammates, by your company, by your project group, by the public who appreciates your efforts, this is not the way to go. It's too complicated. Single purpose building block. Remember that. Yeah, okay. And since we are importing our own module, all right, let's try to understand also the idea of namespace. So we are importing a module that we have written to reuse it in future or in another project. We remember earlier on in our previous video, we were talking about creation of a new namespace automatically by Python whenever you import. So in our original definition of the creation of the birthplace of the function average x and average, all right, their namespace is in this module. Yeah, this is the global namespace. But when we import it into here, the global namespace is this module, not calculations, but calculations dash use. So when we know that when we need to refer to the calculations module's average function, we got to do the dot notation. This much is clear. But what if we have our own calculations? What if there is another package, developed somewhere that is also called calculations? Then we have a problem, isn't it? Maybe your teammate developed calculations for the purpose of calculating taxes, income taxes, right? And unfortunately, the teammate also used calculations as the package name, the module name. So we have a clash. And remember, namespace themselves cannot clash. So this is beautiful in Python. When we import calculations, we can use the as keyword, as, not spelled in other ways. Import calculations as calc, for example. So what this means is that we are importing from that very same module called calculations. If you don't have the ascalc, like in the first place, to use any function within, you must use back the same module name as the namespace name. So this is what happens. This calculation here refers to the namespace, which happens to be automatically copied with the module name. So module name is module name. It refers to which package to suck in the logic. Namespace is the surname, remember, of the variable. So if we talk about average, we need to give the surname, and that's called a namespace in Python, the full namespace name. But with the as feature, these two names can be different. The module is still calculations, so we say import that. But the namespace can be different. So we can call it anything we want. You can call it something sensible, calc, or my calc, or group calc, or just here, calc. So once you do that, I can simply say calc dot average. All right, so when I run this, it will just run fine as well. So what is calc dot average x? It's a function, right? So it is defined. It is not name error over there. So this is pretty cool because it allows us to, independently manipulate these two values without having this enforced equality between the package, the module name and the namespace name. All right, so use this. We'll be using NumPy, Python, NumPy and Pandas packages that have been developed and very widely tested, very stable, very good and powerful, and we'll be having the need to use as to rename the namespace. All right, so pick up on that. Okay, with that, we come to the end of the discussion of this good practice called single purpose building block. All right, so hope you have learned something out of this discussion. Like it, don't like it, examples, counter examples, please comment. And when you click submission of the comment, YouTube will send me a tinkle, and I'll love to see what you have to say over there.